On page 2, we start by talking about the mole ratio. So when I say mole ratio, what it's talking about is the ratio between the numbers of moles of any two substances in a balanced chemical equation. Really, all this is going to be is the coefficients. So here you are using, when you say use, the coefficients. So your step 1 in all of these is going to be to balance your chemical equation. So the coefficients, remember, are the big numbers that we wrote in front of each of the substances in your chemical equation. We usually would balance it by drawing a reactants and products chart. So I'm going to draw them off to the side just so that we have space underneath this to write the mole ratios. But if I start with nitrogen and hydrogen, I have 2 of each on my reactant side, and I have 1 nitrogen and 3 hydrogens on my product side. So to balance it first, if I try to get my nitrogens balanced, I would put a coefficient of 2 here. 2 times 1 nitrogen would change the count on my product side to 2, and 2 times 3 hydrogens would change the count on my product side to 6. Then my nitrogens are balanced, but my hydrogens are not, so a coefficient of 3 in front of hydrogen. 3 times 2 would give me 6. And then everyone is balanced, so my last step is to put what right here? Perfect. So what I mean by use the coefficients to write your mole ratio is that we can relate any of these substances to one another using their coefficients. So I could say that for every 1 mole of nitrogen gas that we used, we also needed to use how many moles of hydrogen gas? 3. So we just used their coefficients and plugged them right in. And I can phrase that in a whole bunch of different ways. I could also say that for every, my pen keeps shutting off, every 3 moles of hydrogen gas that we used, how many moles of nitrogen do we need to use?
1.
Just 1. So it's the same ratio, just written in a different way depending on how the question is asked. So in this, I gave you a couple of questions down here. For every 1 mole of N2 used, how many moles of NH3 are produced? So for every 1 mole of nitrogen gas, we were able to produce how many moles of NH3? 2. So there is no math in this part. It is just about reading your coefficients. How many moles of NH3 are you able to produce if 3 moles of H2 are used up? So if I start with 3 moles of H2, how many moles of NH3 did you produce? 2. So here I related my reactants to one another, but you can also relate each reactant to a product. I could have also written this same ratio as for every 2 moles of NH3 that I produced, I had to use up 3 moles of H2. Same thing with this one. I could say for every 2 moles of NH3, I needed to use 1 mole of N2. So this doesn't come from your formulas. This comes from your balanced chemical equation. So you don't need to think too hard about it. It is just copying the coefficients every single time. And if I go down, I'm going to change my color just to stand out a little bit more. Oops. I will draw my reactants and products chart over here. So I have iron and hydrogen and oxygen. On my reactant side, 1 iron, 2 hydrogens, 1 oxygen. Product side, I have 3 irons, 4 oxygens, and 2 hydrogens. I can start by balancing my iron, but I'm not going to because I have a feeling this one's going to get messed up when I balance this. So I'm going to skip down to my oxygens. I have 4 on my product side and only 1 on my reactant side. So I'm going to put a coefficient of 4. 4 times 2 hydrogens would change that to 8 hydrogens. 4 times 1 oxygen gives me 4 oxygens. and then a coefficient of 4 here, 4 times 2 hydrogens would give me 8. So now my hydrogens and oxygens are balanced, my ions are not, so actually it didn't get messed up. 3 times 1, 3. Everything is balanced, so your last step would be to do what? Put a 1 in the blank for the thing that did not need a coefficient. Perfect. Is that right? Is that what y'all got? Okay. Felt too easy. So then underneath this, we can relate, again, any of our reactants to any of our products, or any of our products to any of our reactants. It does not matter. It just depends on what the question is asking you for. So it says, if you want to make 4 moles of hydrogen gas using your equation, if you don't remember the formula for hydrogen gas, part of the reason that hydrogen gas is going to be H2 is because hydrogen is diatomic. It's one of our Brinkelhoff elements that we listed on the previous page. But the other way that you can tell is by using the context of what else is in your equation. If you look at this, that's iron, so obviously that's not going to be hydrogen gas. This is H2O, that's water, that's not hydrogen gas. This is Fe3O4, no, that's different, that is not hydrogen gas. This one says hydrogen and it says G next to it, so that tells me that it is in the gas state. So when you see it written out like this, use the context of the equation to help you figure out what the formula should be. So H2, so if you want to make 4 moles of hydrogen gas, how many moles of water do you need to use? So if I wanted to make 4 moles of H2, how many moles of H2O did I need? 4. Again, you could write this the opposite way as well, where I said for every 4 moles of water that I used, I could make 4 moles of H2. And then the next question says, how many moles of iron do you need to make 1 mole of Fe3O4? So to make 1 mole of Fe3O4, that's this, how many moles of iron did I need to use? 3. Then the next question says, what if I wanted to make 2 moles of Fe3O4? You would need 6 moles, so I'm going to write that out. So 6 moles of iron. So we could do that as an equivalency, so I could say X is what we're solving for, moles of iron for 2 moles of Fe3O4. So if you multiply these two, you would get 6 divided by 1 would still be 6. What we are going to do is oftentimes not going to be a nice, neat whole number like this, so you will get numbers given to you to convert from moles of one thing into moles of another thing with not such a pretty number, so something like 0.040. We would have to do some calculations, and so we're going to go back to our process of dimensional analysis in order to calculate it using one of those T-charts that we practiced with before. So when we are doing mole-to-mole conversions, you have to always start with a balanced chemical equation. And then to write a mole ratio, you need to use the coefficients. And you're going to compare whatever it is that you started with, whatever your given information is talking about, to whatever the question is asking for. So you're going to use the coefficients to write a mole ratio. So above this, the question would ask us about one substance, but give us information about another substance. We use the mole ratio to get the information that we want about the substance that we want. So this first question says, if you dropped 0.040, I'm going to highlight that, moles of potassium into a beaker of water, how many moles of hydrogen gas, I'm going to highlight that in a different color, moles of hydrogen gas would you produce? So the stuff that I highlighted in yellow, this is what we would call our given. This is our known information. Oops. This is always where you'll start. And then the moles of hydrogen gas, this is what the question is actually asking us for, is how many moles. So this is my question. Every time you get one of these questions, you're going to identify those two pieces of information. What does the question give me? What is my known information? And what is it actually asking me for? If you can identify those two things, you can earn yourself at least partial credit without ever having to think too hard about the question. So if you know that the question is saying how many moles of hydrogen gas, even if you have no idea where you're going to go from here, you can draw a little blank for yourself to put the number in, and you know that the unit on your final answer should say moles of what? Of hydrogen gas. And then the formula for hydrogen gas, just like we used the equation up here to help us figure out the formula, we can use this equation that was given to us to help me find the formula. That's not hydrogen gas, that's not hydrogen gas, that's not hydrogen gas, that is hydrogen gas. So moles of H2. If you can just identify this and show me this much, you will get your point for showing me the unit on your final answer. And that helps you stay focused and figure out what direction you're going to go with your setup. So let's start by balancing our equation. This is one of the cases where I have water on one side, and if I have hydrogen and hydroxide separate on the other side of the equation, it often helps to get rid of H2O and actually put HOH so that we can balance it as hydrogen and hydroxide. So for my reactants and products, I have potassium, hydrogen, and hydroxides. On my reactant side, I have 1 potassium, 1 hydrogen that is on its own, and then the other hydrogen is part of hydroxide, so that's where I count that one. And then on the product side, 1 potassium, 1 hydroxide, and 2 hydrogens. So since my hydrogens are not balanced, I need to get more hydrogens on my reactant side. I'm going to use a coefficient in front of the compound that contains hydrogen on the reactant side. So 2 here. 2 times my 1 hydrogen would change that to 2. 2 times 1 hydroxide would change that to 2. Now my hydrogens are balanced, my potassiums are still good, but my hydroxides are not. So on the product side, in front of the compound that contains hydroxide, I'm going to use a 2. 2 times 1 potassium changes that to 2 now, and then 2 times 1 hydroxide is 2. Where would my last coefficient go? 2 in front of K, and then once everyone is balanced, I can put a 1 right there. So it's fine to think of this as water if you prefer to see it as H2O, but as far as balancing, I think that it tends to make it easier to have hydrogen and hydroxide separate. So I checked off this box. You must always start with a balanced chemical equation. Done. Then we use the coefficients to write a mole ratio using our given information. So here, if you dropped 0.040 moles of potassium, I'm going to plug that into one of my conversion T-charts. So using a different color again, I'm going to take 0.040 moles of potassium. Then when I say T-chart, I'm talking about these things. And if you remember from last semester, when we did dimensional analysis, anything with our conversions, whatever unit that you have in this first box, you're going to bring that same unit diagonal down so that it is able to cancel out. Remember setting these up before?
Yes, ma'am.
So every single time you can earn yourself points for every single thing that you write. So moles of potassium would come down. So start with your given. Your known information will always go in the top of the first box. And then we bring that unit diagonal down so that eventually the moles of potassium and moles of potassium on top and bottom, since this is basically like a fraction, those will eventually cancel out. And then once you have moles of potassium, you can use moles to write a mole ratio based on the coefficients in your balanced chemical equation. So just like the same thing we were doing up here, where we just pulled mole ratios from our balanced chemical equation, we do the same thing down here. The only difference is that now we have kind of a funky number. So if I have moles of potassium, but my question is asking for moles of H2, I can get to moles of H2 by using the coefficients and writing a mole ratio. So according to my equation, for every 2 moles of potassium, I'm going to put a 2 here, how many moles of H2 was I able to produce? 1. That comes from my coefficient. And since moles of H2 is what I was looking for, so I'm coming back here, it's another reason that having this set aside kind of helps you keep a focus on what it is that you're looking for. Once I have that unit in my T-chart, I'm good and I don't need to continue on. I don't need to cancel it out. I don't need to add any more conversion factors. So then if I take this, because I set it up this way, moles of potassium will cancel with moles of potassium. There's nothing else in my equation that will cancel, so the only units that I have left are moles of H2, which is what I wanted. And then to solve this, remember that you multiply every time you cross a vertical line on the top, and then you'll divide by everything that's on the bottom. So when you type this into your calculator, you're going to type 0.040 for that number. You can multiply it by 1, but of course anything times 1 is going to be the same answer, so the 1 isn't going to change anything. And then you'll divide it by 2.
I have Sienna Hoffbauer for checkout, please.
Yes, ma'am.
Thank you.
So 0.040 divided by 2 equals what? 0.02. And your answer, your final unit, is moles of H2, so you can just go ahead and put that on the line. All right, good with example 1? As a reminder on how these are going to be graded, I give you credit for every single thing that you write, which is good and bad. Good if you show your work, bad if you're not used to that. So you would get a point for showing me the correct number in the right place here, and a point for this. This means that if all you do is copy down your given information, you are at least earning yourself partial credit. So a point for a number, unit, a point for this number, a point for your unit, a point for this number, a point for your unit, a point for this number, and a point for your unit. So a question like this would be worth how many total points? 2, 4, 6, 8 points. By just copying down your given information and then giving me the unit that you're ending with, that's 3 points. By recognizing that you just need to move down your same unit, that's already half credit on a question like this. So in a lot of cases, you can get yourself started and at least earn half credit or really good partial credit instead of just leaving the question blank. So try your best not to leave anything blank, even if you are totally lost. So question 2, if I set this up, it says, using the same number of moles of potassium, how many moles of H2O will be used? If it says same number of moles of potassium, that means that I'm looking at my previous question. I started with 0.040 moles of potassium, so I'm going to plug that in. 0.040 moles of potassium. Already, just by writing that and showing that I understand this is going to be some kind of conversion that I put into a T-chart, that earns me 2 points. I know that at the end, when I am done, what unit will this be in?
H2O.
What H2O?
Mole H2O.
Perfect. Moles of H2O. That earned me a 3rd point. If I have moles of potassium up here, I can make it count twice if I just remember that I need to drop my unit down to the bottom, diagonal down. So moles of potassium comes down to the bottom. So I have 0.040 moles of potassium came down to the bottom so that it would eventually cancel out. So again, without ever having to really think that hard about this question, I have already earned 1, 2, 3, 4 points. That's half credit on this kind of question. From moles of potassium, if what you're looking for is moles of H2O, can I go directly from moles of potassium into moles of H2O? Is that possible based on my equation? Yes, okay, we use what we call the mole ratio with our coefficients. So I can put moles of H2O on the top, and I can get from moles of potassium, my coefficient is still 2, so I'm going to put a 2 there, to moles of H2O, which was this one. So for every 2 moles of potassium, I needed to also use 2 moles of water. And remember that anything that is on top will cancel with anything on bottom. So I set this up on purpose so that my moles of potassium would cancel, but it just so happens that these numbers are the same as well, so the 2's would also cancel out, which means there's not even anything you need to plug into your calculator in this case because the 2's cancel. So if you're multiplying by 2 and then dividing by 2, you don't actually have to solve anything. So your answer would just be 0.040 moles of H2O. And again, this question is worth 1, 2, 3, 4, 5, 6, 7, 8 points. Let's set up this next question together, and then I will let you calculate it to solve. I think there was some context that was maybe taken out. So it says, how many moles of CO2 are produced when 10.45 moles of C3H8 are burned in a propane gas grill? So I don't have a balanced chemical equation, so you're going to need to write a balanced chemical equation. I know that my reactants will be over here, my products will be over here. CO2 has to be produced, which means that it will be on my product side. So CO2 is going to go over here, but I'm going to give myself space to put a coefficient. I know that CO2 isn't going to be my only product because if I have C3H8 being burned, that means that hydrogen is also part of this. So hydrogen has to be part of my product as well, but we'll get to that. So C3H8 being burned means that that has to be one of my reactants. If you're burning it, what also has to be present? O2. So give yourself space to put O2, or coefficient in front of O2. And if you have O2 reacting with what we call a hydrocarbon, or combustion of a hydrocarbon, it always produces carbon dioxide and what other thing? Not hydrogen, but a compound that has hydrogen. Water, good. CO2 plus H2O. So remember, combustion of a hydrocarbon always produces carbon dioxide and water. So based on this skeleton equation, you should be able to set up your reactants and products chart, balance the equation, and then figure out how many moles of CO2 are produced with this given information. So I'm going to pause and give you guys a chance to try this yourself. Once you have your equation all the way written out, it's just about balancing it. So you can do your reactants and products chart, or some of you guys at this point have made it past that and can balance them in your head. That is okay when the question is not just asking you to balance it. On your homework, where you're writing mole ratios, I do still want you to show your balanced chemical equation, because a lot of them are not ones that you can do in your head like this. So if I have 3, 8, and 2 for my oxygen, and then on my product side I have 1, 2, and 3. In front of the compound that contains carbon on my product side, I'm going to use a coefficient of 3. 3 times 1 carbon would change the count to 3. And then 3 times 2 oxygens means that I have a total of 6 oxygen atoms from carbon dioxide. Plus, I still have 1 oxygen atom from H2O. So 6 plus 1 gives me 7 atoms of oxygen. My carbons are now balanced and my hydrogens are not. So I need a coefficient on my product side to make this number eventually equal 8. I have H2 over here, so a coefficient of 4 would change that to 8. So 4 times 2 hydrogens gives me 8 hydrogens. Now I have 4 times my 1 oxygen gives me 4 oxygens from H2O, plus I add to that the 6 oxygens I had from 3 CO2. So 6 plus 4 changes this count to be 10 now instead of 7. So I'm just going to erase because I don't have time, or don't have space, I mean. 3, 3, 8, 8, 2, and 10. So if I needed this count to end up equaling 10, in front of O2, what coefficient would help me? 5. Good. I'll erase those so they don't confuse us. So then 5 times 2 gives me 10 oxygens. And then finally, my last coefficient would just be a 1. So this question says, how many moles of CO2 are produced when 10.45 moles of C3H8 are burned in a propane gas grill? So I'm going to start with my given information of 10.45 moles of C3H8. I would bring down my unit of moles of C3H8, so moles C3H8. And I know that what I am looking for is what? What's the question actually asking me for? CO2, but what of CO2? Moles of CO2. So make sure that for each of these, you include your unit and the substance that it's talking about. If you just say moles, that's not going to be good enough because you have moles of multiple things. If you just say C3H8, I don't know if you're talking about grams of C3H8 or molecules of C3H8 or whatever it is. So include the actual unit of moles and the substance that you're talking about. So moles of CO2. And then from moles of C3H8, I can go directly into moles of CO2 using my mole ratio. So moles of C3H8 to this one, I have 1 mole of C3H8 for every, 3 moles, of CO2. That comes from my balanced chemical equation. So moles to moles, I call that a mole ratio. And it comes from your coefficients. So 10.45 times 3 would give us our answer for this. So if I type this into my calculator, 10.45 times 3 equals what? 31.35. Is that what everybody got? Perfect. So make sure you copy it down. 31.35 moles of CO2. So again, this question has 1, 2, 3, 4, 5, 6, 7, 8 total points possible. Let's finish example 4 and then we are good to go. So number 4 says the reaction between methane, which is CH4, and sulfur produces carbon disulfide, which is CS2, a liquid used in the production of cellophane. So starting with your reactants and products chart, if you are still struggling with balancing to the point that you need help on every single question, tutorials is for you. I will take you through as many balancing practice questions as you need to during tutorials. That is also what your homework is for. The Pig Scientist worksheet that's on the back page of your notes will be due next time I see you. It is all about balancing and then writing these mole ratios. So I'm going to take carbon, hydrogen, and sulfur. I have 1 carbon atom, 4 hydrogen atoms, and 8 sulfur atoms. On my product side, I have 1 carbon, I have 3 sulfurs, 1, 2, 3, and then 2 hydrogens. So right away, I see that this one has 8 sulfurs on this side. I have 2 here, so that's going to produce an even number, but this one's going to make it odd. If I put a 2 here, it's going to be 2 times 1 plus 2, so that's 4, so it's not a lot. So I'm going to start with a 4 here, just kind of see where that gets me. So 4 times 2 hydrogens on my product side gives me a total of 8 hydrogens on the product side. 4 times my 1 sulfur gives me 4 sulfurs from H2S, plus I have 2 sulfurs from this. So that gives me 6. So it didn't quite get me to what I wanted, but we're at least on the right track, getting closer to the numbers that I'm looking for, so I'm going to keep that there for now. My hydrogens are not balanced, so I'm going to come over to my reactant side, and the compound that contains hydrogen, I need a coefficient of 2. So 2 times 1 carbon gives me 2, and then 2 times 4 hydrogens gives me how many? 8. So now my hydrogens are balanced, my carbons are not. I need a coefficient in front of the compound that contains carbon on my product side, so 2. 2 times 1 carbon gives me 2 carbons. 2 times 2 sulfurs changes this number to not be 2 anymore, but be 4. 4 plus the 4 sulfurs that I already had for my 4H2S gives me a total of 8 sulfurs. So my 2 and 2, 8 and 8, and 8 and 8 again. So the thing that goes in this blank is a what? Please stop packing up, Jacob. You need to take your notes out. Take them back out. Thank you. All right, letter A says calculate the moles of CS2 produced when 1.78 moles of S8 is consumed. I have 1.78 moles is my given information, so I'm going to take 1.78 moles of S8. Even if you don't know where you're going from here, you should be able to identify what is the question asking us for. What final unit will I end in? Perfect. So moles of CS2. So if I have moles of CS2 is what I'm looking for, I can bring down my unit of moles of S8 so that those two cancel out. And then moles of CS2 will go on top. And then I just use my coefficients to write the mole ratio. So moles of S8, I have 1 mole according to my balanced chemical equation. And then moles of CS2, 2 moles. 1.78 times 2, oops, is 3.56, so that would be my answer here. And again, 8 points for a question like this. And then letter B, this is the last one, and then I promise you'll be able to pack up. How many moles of H2S is produced during the same reaction? So, same reaction, what does that information tell me? Same given. Please stop packing up. Unless you have already solved this and you can come up to me right now and show me, do not pack up. If it tells you same reaction, that tells me you're using the same given information. So if I have 1.78 moles of S8, because that was my given previously, we follow the exact same process. What is this question actually asking us for?
H2S.
Perfect. Moles of H2S. So I would do the same thing, bring down my moles of S8 and moles of H2S is what it goes to. For every 1 mole of S8, how many moles of H2S do I have? And then 4 times 1.78 will give me 7.12. Is that what everybody got? Perfect.